So you might remember when we were multiplying, there were some times where the middle term canceled out and your answer was only two terms. So we haven't looked at, well, how about doing that in reverse and taking this and going back to two binomials. Okay? But the fact that the middle is 0, right, this is really c squared plus 0c. Right, minus 16. There's no middle term. All we have is a equals 1 and a c equal to negative 16. Right? So it will go a little bit faster and it'll be a little bit easier. And after a while, you're going to see a little pattern. So what multiplies to negative 16, right? That would be 1 times this, and adds to 0. Right? And it makes it a little bit easier to get those. So we got a 4 and a 4. So we end up with a c plus 4 and a c minus 4. So the fact that this number is a perfect square makes it a little nice. And you might notice that, like, yeah, 100 is a perfect square, so is 64. And that's why it's called, up here, perfect square. Right? It also says it's a difference. So you'll notice that all these are subtractions. We'll get into why that is a little bit. So you're going to notice the patterning emerging. Okay? And keep in mind that it's going to only work with a difference, subtraction, of two perfect squares. So remember, perfect squares are like 1, 4, 3 times 3, 4 times 4, 5 times 5. So it has to be very specific numbers. 6 times 6, 7 times 7. So you're going to see a lot of these kind of numbers, perfect squares, on a lot of these problems. And if it's not one of these numbers, you're going to have to maybe do something to make it work. So also do a check just to verify that everything you're doing, you can always do a check and see that, oh yeah, that's going to be c squared. That's going to be minus 4c. This is going to be plus 4c. Right, this is going to be minus 16. And of course, the positive and negative 4c end up canceling out, equaling 0. And we get c squared minus 16, which matches with our original, so we know we did it right. Okay. So remember, on all these, no matter how confused you might get and how unsure you might be on your answer, you can always do this 5 seconds of work and see, is it the right answer? You don't have to turn in a quiz or a test and think, I wonder if I did it right, or what did I get on this quiz, what did I get on this test? It's easy to check and pretty quick. Okay. So give that a shot on number, let's see here. Oh, you can do this one, number 3. Don't worry about the order. The fact that they're perfect squares is what's the key thing. So even though like the number's first here, if you have like a perfect square, like 64, which is 8 times 8, and a variable squared, okay, the same pattern will always work. So we'll have, right, what multiplies 64? Okay, 8 times 8. And since it's in front, I'm putting the 8s in front. We're used to putting the numbers on the ends, but it's in front here. Switch it up. And what multiplies to y squared? All right. Y times y. And you'll notice that for this to work, you'll get one that will be positive and one that will be negative. Right? So we'll have one that's plus, one that's minus, and then you can check your answer and see, yeah, 8 times 8 is 64. It's the 1 plus and 1 minus that leads to the one that's negative on the inside, and there's another one that's positive on the inside that causes the whole middle to cancel out. So that's why we have one that's positive and one that's negative. That's what creates that 0 in the middle. So we get just 2 terms in the final answer, and they'll end up matching. So very important to have one positive, one negative. If they're both positive, it'd be 8 plus 8. You'd have 16y. And you'd have 3 terms in our answer. So very important. One positive and one negative. And then the check. All right, go ahead and do number 2. See how that goes. So for number 2, we ended up with what?
Yeah. D times D is D squared. 10 times 10 is 100. One positive, one negative, and then do the check. It will check out. So you can see that pattern. But you do have to have two things. You have to have perfect squares, right? Like something squared for the variable and a number that can be written as something squared, 10 squared. And you have to have the difference. It has to be the minus, because otherwise we won't get a zero term in the middle. Okay, all right, so let's go down here. Same, right? You know, what times what equals W squared? You know, W and W. What times what equals A squared? A and A. And then, of course, one positive, one negative. Right? So after a while, you can really start using this pattern to help yourself out. Instead of doing a longer version, using the grouping or the box or something. Just use the pattern instead. And no matter what, the check should always work out. So remember, since we have one positive and one negative, that will lead to the zero when we're doing the check. So you got to have one positive, one negative. So that's how we end up with W squared and negative A squared as the final answer. And it matches up. All right. Take a look at number 7. Are those perfect squares? 5 and 20. Number 7. No, right? So remember, perfect squares are 1 squared, 2 squared, 4, 3 squared, 9. We need to have them be perfect squares. That's why it's called a difference of perfect squares, right? If we don't have these numbers, the pattern will not work, because we can't write, you know, what number times itself equals 5. Well, it's not a perfect square, so that can't be done. So, but you might notice that, like when we're doing the box and everything else, can we take some number out of 5 and out of 20? Can we take the same number and factor it out of both? Okay, and what number would that be? Yeah, we can take a 5 out. Right, so if it doesn't work, try removing a factor and see whatever you're left with and see if that works. So if we take a 5 away from the 5n squared, what are you left with? Okay, we're left with just n squared. So that's good news, right? That's just a square, n times n. And if you take the 5 away from the negative 20, what are we left with? Negative 4. And that is a perfect square. So that part, now we can actually do the factor. Okay, so just ignore the 5 in the front and just do, you know, the red part here, just like number 1 and number 2. Okay, so what times what equals n squared? N times n. Okay. And what times what equals 4? 2 and 2. And then, of course, one's positive and one's negative. So maybe not at first, you can't use perfect squares, difference of perfect squares, but maybe by taking out a GCF, taking out some factor, what you're left with, you will be able to do that. Now check this. Does this multiply back to this original problem? So n times n, right? N times negative 2, 2 times n, right? And 2 times negative 2 is negative 4. Sure enough, we get the 0 on the inside, right? But what we're left with is n squared minus 4. Now, does that match our original problem? No, it does not. So this is not correct. What's missing? 5. So that 5 we took out before, we have to leave it there. Otherwise, when you do your check, it doesn't actually multiply back to what you started with. So I'm going to leave this 5 throughout the whole problem and just leave it in the front. That way, when I do my check, I'll have one more step here. You know, pretty much the opposite of what we did earlier. We took the 5 out. Now we're just putting it back in. So 5 times n squared is then 5n squared. And 5 times negative 4 is negative 20. And now they do match. So there's a common mistake of sometimes people, they take out this factor in the beginning, and then their final answer, they only put like the red part, but you do have to have that number you pulled out, you do have to have that on your answer, which is new, because as of right now, you guys always had your answer was just 2 parentheses, but you now might have a number or a number and a variable just sitting in the front there, also on your answer, if you indeed took it out and begin with that start of the problem. So again, this is where the check really starts becoming useful. Maybe up to the point you're like, okay, I know it's going to check out, I don't need to write it down. As soon as we start having these GCFs, it's like, yeah, very good idea to check, just in case you left it off. It will remind you to put it in your answer. Okay. So let's look at one more that's similar. So 3 and 27, are those perfect squares? All right, can we multiply the same number times itself and get 3? Can we multiply the same number times itself and get 27? No, like 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. They're not equal to 3. They're not equal to 27. So what can we take out from both of these? What can we factor out? Yeah, they each have a factor of 3. So remove a 3. This is just the reverse of the distributive property, which is called factoring. GCF, greatest common factor. What's the biggest number that goes into 3 and 27? That's 3. And then you work backwards. If you take 3 times what gives you 3a squared. Okay. 3 times what gives you the negative 27c squared? Negative 9c squared. So now we have perfect squares, right? We have a 1 and we have a 9, which are perfect squares. 1 and 9, so we can use this pattern. But remember, throughout the whole rest of the problem, this 3 must remain in the very front. You cannot just drop it off. It has to stay there. Otherwise, when you do the check, it will not multiply back to what you started with. All right, so what times what equals a squared? A and A. What times what equals 9c squared? Yeah, 3c and 3c. Right? 3 times 3 gives you the 9. The c times c gives you the c squared. And what about the signs? One's positive, one's negative, right? Otherwise, we won't get the 0 in the middle when we do the check. So that's a must. One's positive, one's negative. So this is the final answer. That's the correct answer for this problem. And then you can do the check. So remember, to do the check, multiply the red part first. Just go in reverse order. So the first thing you did was to take the 3 out. So when you're multiplying it back together, that should be the last thing you do. So multiply the 2 binomials back together. Right? Like this. And then you'll just have that 3 just kind of hanging out in front. Then once you show, okay, the middle terms cancel out, 3ac minus 3ac is 0. Okay. And you're left with a squared minus 9c squared. Then go ahead and distribute it back in. So we get the 3a squared, and 3 times negative 9 is negative 27. Right? So basically you're doing each problem forward and backwards. Double check and make sure it's all correct. Okay, so I can leave you with that. Real fast on number 10, just flip it over. Notice here that you can take out a 2 because 2 goes into both of those, but that they both also have an x. So it doesn't have to be just a number. It can be a number and a variable when you're doing your GCFs. Okay. Basically anything that can come out, take it out.
Okay? And if you have a multiple choice of like, well, I could take out a 2 or a 4, always take out the biggest number possible. Take out the biggest number possible. So we'll end up with x squared, right? Take a 2 away and take an x away. We're just left with 2 x's, x squared. We take a 2 away from the 8, we'll be left with a 4. And we took the x out, so what you're left with here is something that's a difference, subtraction, of 2 squares, x squared and 2 squared. So you can finish that and do the check. Real fast, by looking at every problem on the back, which one is prime? Yeah, what problem is fundamentally different from all the others? Look at all those on the back. All these problems have in common something, well, several things, but one thing sticks out pretty fast that, well, all the other problems have this, but this problem does not. Can you tell what it is? Maybe go back to the title of what we're doing. Difference of perfect squares. 13. Yeah, look at 13. What's different about 13? Yeah, it's not a difference. So you'll notice if you try to go through and use the shortcut here that we're learning today, and you try to make this 8t and 8t to get 64t squared, and you tried to do 3 and 3 to get the 9, and then you did 1 positive and 1 negative, and then did the check, it would come out to equal 64t squared minus 9, right? Because it would be 3 times negative 3. It wouldn't equal positive 9. So that's why it will not work. And someone might say, well, why don't we just, if we need to be positive 9, why don't we just make them both positive, and then it'll be positive 9. But remember, the whole reason we had 1 positive, 1 negative is so when we did the check, right, we would have the center cancel out. So if we have them both positive, we'll get 24t, right? But then we'll get another 24t. Instead of getting 1 positive, 1 negative, we'll have 2 positive 24t's, which don't cancel out. They would equal 48t. So if you just make them both positive, that doesn't lead us back to our original problem. So whether there's 1 positive, 1 negative, it doesn't match. Whether if we make them both positive, it still doesn't match. So that's why, unless it's a difference, this whole thing doesn't work. So that the title is actually very important. Those 2 criteria must be met, and must be a difference, subtraction, and they must be perfect squares. All right. So given that information, you can go through and finish up the rest of it, and we'll go ahead and check over that. And number 4 from 28, last night's homework. We'll check both of those tomorrow.